All right, here we go. So, your logarithms have covered, we've talked about this last year. So this is basically everything I just gave Algebra 2 last period. So, I expect you to have this. Okay? So, now you do. Okay? Now you may not know how to use it because you may have forgotten from last year to this year. But you're going to be pushed harder this year, okay? So here's the thing. You have to know that this is an if. You have to know that this is a biconditional then. Okay? All of you have had me for geometry, so you know that. Right? You remember the arrow is then and the 3 bars is if. Right? So if you have a logarithm base b of x and it equals a, then you have a power of base b to the a is equal to x. Now this correlates with this statement that I made up myself, right? Remember that whole statement I said, hey, if you have a log of a base of a number, it's equal to an exponent. And in the same aspect, you have the base raised to the exponent is equal to the number. Okay? So that's just a different way of looking at it, and I like to give you guys both ways. Alright? Remember, everything is derived off of this power. And a power is made up of a base and an exponent. Okay?
Yeah.
Right, Cash?
Yeah.
Okay. So, then we have the log base b of x. If I want to change that so I can put it into the calculator, it has to be at base 10. Okay? Now there's a rule for you guys, because you guys are pre-cal. There's another rule that I want to put here, and that is, it's log base 10 of x over log base 10 of b, but I can also put it to any number I want. So I could actually say it's log base y of x over log base y of b. I don't have to make it 10. I can make it any number. The reason why I make it 10 is because base 10 is what's in your calculator, right? But what if you're working with a problem on your test, right, or on this in this book, and it says it's equal to log base 5, but you're talking about log base 2 on the other side. When they're different bases, now you got to make them the same base. So you can actually change that log base 2 into a log base 5 by going, log base 2 of whatever number you were doing, and log base 5 of whatever you're doing over log base 5 of 2. And now they're all in log base 5. You see what I'm saying? Then you multiply both sides, and we'll deal with that later. Okay. So that's one way of dealing with it. I think I found other ways to deal with it that I like better, but the book gives you this, so I thought I better. Alright? Next, some really good powerful rules. 1, the log base b of 1 is equal to 0. Okay? And the reason that is because b to the 0 is equal to 1. Okay? Alright, the other big rule we use is, ln x is the same as log base e of x. So don't tell me later on in the year, we never did ln. Okay? Because we do. And we will do a lot of it this year. Okay? Even in Algebra 2, I'm going to be pumping them with a lot of it. Alright? Then, given that, into all log base in, or e is ln, the natural log. Okay? We talked about that last year. Alright, so then we have, if ln is 1, if you're taking ln of a number 1, that's going to equal 0 too, right? Because e to the 0, any number to the 0 is equal to 1. Does that make sense? Okay, next, ln e is equal to 1, then that means the log base b of b is equal to 1. So anytime you have log base 2 of 2, if you have log base 5 of 5, if you have log base 12 of 12, those are all 1. Does that make sense? They will throw this at you, I guarantee you. Okay? Next, the adding rules. Remember, exponents are logarithms. So when we multiply powers, when you say, hey, x to the 5th, right, is multiplies x to the 7th, what do we get?
X to the 5th multiplied by x to the 7th.
Yeah.
X to the 30th.
Hey, Matthew, you want to turn that
Nope.
down a little?
X to the 5th, can you turn that down, Matthew? Are you listening?
X to the 12th.
X to the 5th times x to the 3rd is what? X to the 8th. We added the exponents, right? So, what is a logarithm? What is a logarithm? It's an exponent.
It's an exponent.
Yeah. So when you multiply powers and you add the exponents, what happens when you add the exponents? When you add the logs, you multiply the numbers. That's where this is coming from. When you multiply the numbers, when you add the logs. So when you subtract, you divide. Okay? When you take a power of a power, what happens when you have x to the 10th raised to the 3rd power? Now that's x to the 30th, right? Because you multiplied, right? So when you take a power of power, you multiply, right? Okay? Same thing. So if I take a power inside the power, I'm going to multiply the exponent. I'm going to multiply the log. Does that make sense? And that's where you get a times the log of x. Now the other thing we need that I didn't teach last year, and it's really important, is this b to the log base b of x is equal to x. Okay? What that means is if you have e to the ln of x, because ln is base e, right? Anytime you have a power or a base raised to the log of that same base, it just equals the darn number that they're talking about. Okay? So, whatever's up there, that's what this is. Does that make sense? I never use it, but for some reason they throw it on this, so it might be on the test somewhere. Okay? Alright, let's go through this homework now. Okay, really quickly. That's still working? Okay. Number 4. Okay, this is 5.4. Number 4 says, hey, find the value. So I need to find the value of this. Now think about this, and you guys you're going to have to learn to do this, okay? Remember, what is a cube root? It's a 1/3 power, right? So what you have to do is you have to go, log of 0.01 raised to the 1/3 power, right? And then what's going to happen is, sorry, can I talk about this one? Okay. I better talk about this guy so we can get another rule for it.
Is that purple or brown?
That's black. Because you don't have brown. I wouldn't use brown.
Well, I could just use pink for it.
Okay. So this pink one, let me talk about this pink one real quick. If you have a log base b of some number, x, is equal to log base b of some number, y, then you're going to get x is equal to y. Because if they're the same bases, then you can get rid of the logs, and you can just have those. Okay? So that's our last one right here. Is if you have log base b, or even ln of x, right, is equal to log base b of y, then you will have x is equal to y. Okay? That's all that is. So I'm going to erase that pink part so I can write more over here. That's.
Were we supposed to write the pink part down though?
No, not there. I wanted it right here. I was just going to talk about it. Sorry. And then I forgot to talk about it. So let's start again with 5.4 and do problem number 4. Okay? Problem number 4 is if I have a cube root, then that's a 1/3 power. so I put this to the 1/3 power. What do I do then? If it's raised to the power, I can put it out in front, right? That means that I can... Where are all my pins? That means that I can take this and go, oh, 1/3 of the log 0.01. Now think about this. 0.01. 10 to what power is 0.01? Well, that's 1/100th, right? If I think about that, that's 1/100 is equal to 0.01. Does that make sense? So isn't that 10? Isn't that 1/10 squared? Right? 100 is 10 squared, right? Okay? So isn't that 10 to the -2? Because I can just bring it up, right? Using my powers, my negative powers. We talked about that yesterday, right? So my negative powers, I can pull that up and make it negative, right? So what that means is this is what? Is the exponent. So how much is log of 0.101? It is -2. So what is 1/3 times -2? -2/3. Right? Now you could throw that in the calculator, but you didn't have to. Okay? So if they make you do it without a calculator, like this one they didn't make you do. But I realized, wait a minute, I can do this without a calculator. I'll do it without a calculator. You could have plugged this into the calculator, but the reason why I wanted to do it without is because you will be asked to do problems this hard. Okay? So you're going to have to be changing these cube roots into 1/3. You're going to have to change the 5th roots into 1/5. You know what I'm saying? Okay? Precal is a whole nother level. Alright. Now, with that said, they want me to put this in exponential form. What's the base here? What's the base of a log? Does it show a log? 10. So we got base 10. What's the exponent? -3. And what's the number we're worried about? Bam. That's what they wanted you to do. They just wanted you to learn how to put it into exponential form. That's it. Simple. So we're just remember running it from exponential form to log form, from log form to exponential form. Okay? Alright. So this one, we're going to put in exponential form. What's the base of ln? Did I let you guys catch up? Is that thing still going?
Yeah.
Okay. What's the base of ln? Come on, guys. You guys know?
10.
No. Log base 10. What's the base of ln? Huh?
Wait, never mind.
ln.
0, 1.
You guys not speak sign language?
5, 2, E.
E. Right? Remember? The base of ln is log base E. Okay? So I know that the base is E. What's the exponent? Remember, the logarithm equals an exponent. So your exponent is this, which is what? 2.3026. Okay? And then it equals the number. So what's the number? That's your number. So remember, log of the base of a number equals an exponent. Okay? So if you want to go back to the base function, okay? You just take the base, the exponent, and it equals the number. So the number is 10. Come on. Focus, people. Focus. I know you can do this. I know you can. All right. Next. We got to put this in the log form. I know you guys know this. What's the base?
What, 10 to the third equals 1,000,
So what's the base?
base 10.
10. Good. So it's log base 10. Okay? All right. What's the number? 1,000. Good. And what is the exponent? Okay? That's it. That's it. Okay? Now, do I need that 10 there? No, you don't have to write that. You could write it as log of 1,000 equals 3.
Whoa, you guys are gross.
Okay? Alright, next. I need to put this in log form. I need to put this in log form. Alright, so what's the base of the log? What's the base of the log? E. So what are we going to use? Are we going to use log base E or are we going to use ln? ln, good.
Wait, I have a question. How do you know when to use ln though?
Whenever the base is E.
Oh.
Okay? It's a good question though. Okay? ln is always base E. Okay? ln is always base E. Okay? So ln, what's the number?
The one on the other side.
Yes, the one on the other side. So 0.0183. And it equals the exponent, which is?
I didn't even write the
Nope.
Negative.
-4. Right? Right?
I knew that.
Okay.
I was just trying to trick them.
Okay. No.
I think you should like try to explain it another way because like the more you try to talk about it, the more you get confused.
We're just doing problems right now.
I only said it for 3 seconds, so.
We're just doing problems. These are the problems. Okay? These are only part of your problems. You have to do, your homework is 1 through 57 odd. Hey, we're not done, are we? What time we at it here?
No, that's
5
fine.
minutes, 4 minutes.
Okay. Alright, what's this one? I gotta evaluate this, okay? I have to evaluate. What does evaluate mean? Solve it. Yeah, do it. Okay? So, what do I do with that thing out in front? What do I do with that power? When I'm taking a power of a power, right? We multiply. So this piece comes out front. So I get the square root of 43 times the log of 10. Now what is the log of 10? What is log base 10 of 10? What is log base B of B? What'd you say? Did you say 1? Yes. Okay. I don't think we wrote that one down, did we?
I don't think so.
You need that one though. That's an important one. Log base B of B is equal to 1. I didn't write that one? Oh, here it is. I was going to say, how did I do it? Okay? It's important. Alright, that means log base 10 of 10 is 1. So that means this is the square root of 43. You're done. That wasn't hard, right?
Thea, shut up.
Guys, if you're going to be in here, be good.
Yeah.
This is tricky.
Wait, how do you know if it's base?
Huh? Oh, if there's no base, it's automatically 10.
What do you know? Wait, what do you mean by that?
If they don't show a base, then it has a base of 10. If it's just a log, remember I wrote up here, if it's just a log,
But I'm not even gonna say it because she looks in there.
where do I say it?
No, it's because he doesn't even know after.
If I have just a log, it's a log base 10. Oh, I talked about it before and I erased it. But yeah, if you have log base 10 of x is equal to log of x.
I was gonna say.
And
Okay.
you said it'll automatically be.
Wait, go be.
Yeah, if you don't have a base there, that means it's like that square root deal. Remember this?
What were you gonna say?
There's a 2 there, right?
Wait, where'd you write?
There's a 2 in there, right? If I say the square root of 9, well, we know that there's a 2, but we never write it. Logs are the same thing with 10. We never write 10. Okay? Is that still going?
Yeah.
Okay. Ln, we never write E. So with logs, we don't write 10, and with ln's, we don't write E. Okay? Now, if we write something with a log, then that's a different base than 10. Does that make sense? Okay? Alright, so what is, remember, when we're taking Ln of E, what can we do? When we have a power, we put it out in front, right? So that just means I get Ln of E. Sorry.
Sorry.
Guys, come on. X plus Y times Ln E. Now, what is the Ln of E? Dorina. Cash.
So,
What's the Ln of E?
ln of e,
Yeah.
1.
Yes. So that's just 1 times X plus Y. So it's X plus Y. That's it. Okay?
Can you wait to do the other ones tomorrow?
Alright. I'm going to finish them on the video. Okay? So next, we have a rule here. If this base is raised to the same base ln or log, then it's just equal to this. That's done. And then we're talking about range. Logarithm, you can't take a log of a negative number. Think about that, right? If I'm taking some number raised to a power, it's going to be negative. How can you do that? Can you raise 2 to some power and get negative? No. You'll never get a negative, right? So this cannot be negative. So 2 minus x cannot be less than 0. Okay? Okay? So it has to be greater than 0. Okay? So then I solve it.